The concept of blockchains and smart contracts can be intimidating to approach even as an experienced developer. But if you already understand the concept of a cloud function and implementing security without secrecy, similar to Firestore security rules, then you should already have a reasonably solid foundation to find your footing in this weird new Web3 world. If you don't already understand these concepts, don't worry, we're still going to walk through an example step by step, as seeing how everything pieces together can help a great deal in understanding all of this. So we're going to deploy a smart contract to an Ethereum testnet that contains some functions, and then we are going to use those functions in our front-end app. And so this is the front-end application that I've got set up with Angular. And I'm going to issue 2 challenges for you to complete as you follow along with this video that will help solidify some of these concepts and get your toes wet in the Web3 world. These challenges will involve interacting with the smart contract that we'll be building in this tutorial. So the first challenge is this: install the MetaMask Chrome extension so that you can create your own Ethereum address for interacting with the smart contract we will be deploying. And once you have MetaMask, make sure that you switch it to the RinkBuy test network. If you want to interact with a smart contract that involves changing the state of that contract, that is to say it's not just a read operation, then you'll need to pay a gas fee. So this will use a small amount of Ether from your wallet. Since we are using the RinkBuy test network, this is extremely cheap, not like real Ether on the Ethereum mainnet, but you still do need to get some test ETH in the first place. So there are faucets available which exist for the purpose of giving you a small amount of some token to work with. So I've included a link in the description to a RinkBuy faucet, but to prevent spam, it can take some time to receive these funds. So the challenge once you have your funds and your wallet set up is simply to interact with the smart contract using the app from this video, and to add your public address to the Web3 Explorers list here. And to do that, all you'll need to do in the end is click this button. And I'll include a link to this live application in the description. Now, if you're feeling a bit more adventurous, I'll also be including another function in the smart contract to add people to a Web3 champions list. A smart contract is public and can be interacted with by anybody. You don't need to use the front-end app I've provided. Now, I don't provide a way to interact with the function that will add you to the champions list in the Angular app I've deployed. So you'll need to figure out a way to add your address to the champions list using any method you can think of, but I've included some hints to help get you started as well. Okay, so let's get on to deploying the smart contract. There's all sorts of ways you can set up a development environment for building Ethereum smart contracts, and it's probably best to set up a proper local testing and building environment, but I want to keep this video as low friction as possible. So if you go to remix.ethereum.org, you can view some example contracts, edit them, and deploy them right from your browser. Smart contracts are written using the Solidity language. I'm not going to explain all of the relevant Solidity syntax and concepts in this video, but you will find that it isn't too dissimilar to writing object-oriented code with JavaScript or TypeScript. Hopefully it will look familiar enough to follow along, but I'm not assuming that you understand how every function works. So you can feel free to follow along and deploy your own contract if you want, but it isn't required for the challenge. So we're going to use the owner contract that we're looking at now as a base for our own contract. And you can see that there are a few contracts in here by default. There's a storage, a token, ballot, and owner contract. And the 5th contract here, Explorers, is the custom one that I have added. Now, the reason I want to use this owner contract as a base is because it has some important security considerations built in. So you can see that like a normal sort of class we might expect to see in TypeScript, we have a contract that has some member variables, a constructor, and some functions. So the constructor runs when the contract is first created. Any function that is marked as public or external can be called by anyone interacting with the smart contract. A view function just reads data. It doesn't change the state of the contract, and it won't incur any gas fees to interact with it. The change owner function, on the other hand, changes the owner variable to a new address. And so interacting with this function will incur a gas fee. We also have an owner set event defined that we emit when the owner changes. This will allow us to listen for changes on the smart contract. And so if we were listening for that event in our front-end application, we could react to changing state in the contract. And finally, we have this concept of a modifier. So in this case, we require that message.sender, which will be the address of the person who is interacting with this contract, is equal to the current owner of the contract. So if this requirement fails, then the execution will be terminated. If it passes, it'll proceed onto this weird underscore statement that just returns the execution flow back to normal. So we can then attach this isOwner modifier onto functions that we only want the owner of the contract to be able to interact with. Remember that anybody can interact with a smart contract. So if we want to stop certain addresses from performing certain actions on public or external functions, then we need to code that into the smart contract. This isOwner modifier will prevent everybody but the person who has the private key for this specific address from interacting with this function. A smart contract is also immutable. Once it is deployed, it cannot be updated. If you make a security mistake, you're stuck with it. The only way to update a smart contract is through dynamic things that have been coded into the smart contract, like how this contract has the ability to change the owner by calling the change owner function. So this changes the behavior of the contract, but it doesn't change the underlying code. If you want to change the code, then you need to deploy a new contract. So that's the general idea of what is going on here. Now we want to add our own functionality to it. So as you can see, I've created a new contract called Explorers, and we just have a basic template set up here. And so you will need this little license comment here, otherwise the Solidity compiler is going to complain about you not having it. Then we need to define what version of Solidity we want to use. In this case, we want a version greater than or equal to 0.7 and less than 0.9. We then import the owner contract that we want to use. And then we set up our new contract just by writing contract explorers. And since we want to extend the owner contract, we say that contract explorers is owner. So now everything in the owner contract is going to be available in this contract, just like it would be if we extended a class in sort of normal object-oriented programming. So to this contract, we are going to want to add an array to store explorers addresses, an array to store champions addresses, a function to add explorers, a function to add champions, a function to retrieve explorers, a function to retrieve champions, and finally a function to delete all explorers and champions that is only accessible to the owner of the contract. So to start off with, we are going to add some variables to hold our explorers and champions. So this is an array of addresses, and an address is just a special type in Solidity which represents a address for an Ethereum account. So if I bring up my MetaMask, this is an Ethereum address. And I'll just paste that there so you can see. So this is the type of data that is going to be stored in this array. Next, we'll add our functions to add to the explorers and champions array. These are both public because we want them to be called. And all they do is take the sender address. So if I'm interacting with this smart contract with this address, message.sender is going to be equal to that address. And then I just push it into the relevant array. Now, it is possible with Solidity to automatically create getter functions by specifying a variable as public. But in the case of the array, it doesn't actually work exactly how we want it to. What that will do is allow us to retrieve a specific element from the array. So when we call the getter, we need to say which element in the array we want, and it will give us that. But we want to actually return the entire array. So we're going to add some additional functions for getting that for us. So this is marked as a view function because it doesn't change the state of the contract, and it's going to return an array of addresses to us. And this is just using memory. With Solidity, we can use memory or storage. So memory is cheap and isn't going to incur gas fees because it doesn't actually need to be stored on the blockchain. It is going to be lost as soon as this call is finished. But if we want to use storage, then that is going to have to interact with the actual blockchain. And so that's where we're going to incur gas fees. Now let's add our function for clearing all of the data in this contract. So the key difference here is that we mark this one with the isOwner modifier, and this is available to our contract because we are inheriting from the owner contract. And then we just empty the arrays by calling delete explorers and delete champions. And the last thing we're going to do is add some events so that we can be notified when a new explorer or champion is added. So we'll just add those two events, explorer added and champion added, and that is going to contain the address of the explorer or champion who was added. And then we will just make sure to emit that event whenever an explorer or a champion is added to the contract. Okay, so I'm going to hit save on that. That is our contract done, and now we can move on to compiling it. And this is also going to tell us if there are any errors in our contract. But remember, your contract can be perfectly valid to the compiler and still be full of security holes or be extremely inefficient with data storage, which will lead to high gas fees. So all we need to do is come to this compiler tab here, and then we just hit this compile button. So once you have compiled your contract, you'll want to make sure to save its ABI, which stands for Application Binary Interface, which basically describes the methods available in your contract. So we can click on this little ABI button down here, and that is going to copy it for us. And I'm just going to save that in my front-end application. I have an abi.json file that I'm just importing. So I'm just going to make sure to paste that in there and save it, and I'll be able to use that later. Okay, so now we're on to the deploy stage, which is this next little item in the tabs over here. So before deploying this to the blockchain, we can do some testing first by deploying it to the JavaScript virtual machine. So this will just be stored in memory in the browser and will allow us to interact with the contract. So we want to make sure that's set to JavaScript VM. We want to choose the contract we want to deploy, which again is the Explorer's contract, and then we will click deploy. So once that's deployed, we'll see it down here in the deployed contracts, and we can expand that to interact with the various functions that we added. So if we click the get owner method, which was from our owner contract that we're extending, we will be able to see the result of that. And if we check the account that we actually deploy this with, it starts with 5B and ends in C4. We can see that here in the decoded output, we can see that same address there. It begins with 5B and ends with C4. Now notice that if I click on the clear data method, that is going to work. We have a little tick there because we are currently using the account that we deployed this contract with, which is the owner account. But if I say try to go to this other account here and I try to call clear data again, we're going to get a failure because this address does not own the contract. But what I could do if I wanted to is I could copy this address, and then I could switch back to the owner of the contract, call the change owner function with the new address. And now I won't be able to call clear data from the original owner because I'm no longer the owner of that contract. Now I have to go to this other account in order to be able to call that owner only function. So I can click on get champions and get explorers as well because these are just public functions anyway. And right now we can see that there are no addresses in there, but if I click add explorer, and then I try get explorers again, we can see that that address has now been added to the explorers array. So once we're happy with this contract, we can deploy it to the RinkBuy testnet. Now this still isn't really deploying it for real because RinkBuy is just a testnet, but it will allow other people to publicly access this contract. So what we want to do is just change this environment option to injected web 3. And then I'll just make sure that I am deploying the contract that I want, which is the Explorer's contract, and then I'm going to click deploy. Now, when I go to deploy this, this is going to ask me to confirm it through MetaMask because I do need to pay the gas fee in order to deploy this contract. Again, we're on the RinkBuy test network. which means that we're only using this test ETH here. Make sure you're not deploying to the main Ethereum network. So I'll just click confirm. And once it has finished deploying, we can interact with the actual smart contract on the blockchain, just like we were with the JavaScript virtual machine. And we can copy the address of the smart contract to use in our application or wherever else we want to use it. So if I just copy that address, we can jump over to the rinkbyetherscan.io website, and I could paste that address into the search box, and that is going to bring up the smart contract from the actual blockchain. So if we click contract, we will just see the compiled bytecode, but don't let this give you a false sense of comfort that your contract is private or secure. We can just as easily decompile this bytecode to see the underlying values. So if I've made a mistake with this contract that you can exploit, feel free to hack it and post a comment below to teach us all a lesson. Now, the final part of this tutorial will be interacting with our smart contract through a front-end application. Now remember, you don't need this front end to interact with the smart contract. It just provides a nicer user experience. So I've built this with Angular, but it doesn't really matter what you are using for the front end. And this is where the challenge that I mentioned earlier comes into things. So I want you to see if you can use this application to add yourself as an explorer to the smart contract. And if you're feeling like diving in a bit deeper and putting on your hacking gloves, see if you can add yourself as a champion. There is no button for adding yourself as a champion in the front end, but the function in the smart contract is public. I'll just be quickly going over how the smart contract is integrated into the front end, as a lot of what is going on in this application is Angular specific. If you are interested in another video or article expanding on what is happening specifically in Angular here, let me know in the comments. And I'll also leave some notes in the description to help you on your way if you are using Angular, because there are some configuration options you need to set up. So the code I'm using here makes use of the Web3 library as well as the MetaMask Detect Provider package. And interacting with the smart contract on the RinkBuy testnet will also require an account with Infura. And you can see my Infura WebSocket link here along with my API key. Please don't use that one, please use your own. So in order to interact with the blockchain, we need to communicate with a node on the network. We could run our own Ethereum node if we really wanted to, but that's a lot of work. Infura provides a service that allows us to use them for this purpose, and they add some extra niceties like caching as well. And they have a free usage tier, which I think is 100,000 requests per day, so you can play around on it. So just go over to the Infura website, sign up for an account, and get your API key. So to set up the smart contract that we just deployed, I'll need to supply the address of the smart contract to web3.eth.contract. So this is currently using the old contract I was testing with, so I'll just update that to the new one. And we also need to supply the ABI, which again, I'm just importing as a JSON file. And remember that you can get these from the Remix IDE if that's what you're using. We can get the address of the contract just under deployed contracts here by clicking the copy button. And the ABI is back in the compile step just down the bottom here. And just make sure to set that to Explorers, compile it and grab your ABI. And this interface can be a little tricky because if you notice, when you click compile, it goes back to the owner contract. So just make sure that after you compile it, you switch to the contract you want the ABI for, and then you click the ABI button. I'm adding this warning because I may have been bitten by this before. So now that we've got our ABI and our new contract set up, we'll be able to interact with that contract through this .contract. And you can see what I'm doing from this point on is I'm just using a service here with an init method to get the initial data set up. I call the get explorers method and the get champions method. That's going to return whatever data is currently in the contract. And then I just have an observable set up that I am emitting that data out onto to pick up elsewhere in the application. Again, I'm not going to go over the Angular specific stuff here because you might not even be using this particular format. And then I call this listen for updates method, which just handles listening to those two events that we added to the contract, Explorer added and champion added. And what that is going to do is just take whatever value was just added to the contract, and it's going to update the data in the application. And the rest of the code in this init method is just related to the challenge. This just includes the hints that I'm leaving in the console to help add yourself as a champion. And then the only other interesting thing here is the add explorer method, which is the button that will allow you to add yourself as an explorer. I have a bit more information on about integrating with MetaMask in a separate video, so I'll link to that. But the basic idea here is that we are requesting the user's account from MetaMask. We set up the transaction parameters. I've included all of the parameters here for reference, but we only need to specify the contract address that we are sending it to, the address that the request is coming from, and then the data, which will be the function we want to call. But it's important that we call the encode ABI function on the function we want to call, because that's the data format that is expected. If you just supply this.contract.methods.addExplorer, it isn't going to work. So once we have those transaction parameters, we can send that request off with provider.request ETH send transaction, and then we just pass along those parameters. And that's going to handle popping up the user's MetaMask window. It's going to get them to sign, confirm the transaction, and it is going to send it off. So let's just quickly jump into the Angular application here. You can see this is all empty now because I've switched to a new contract which doesn't have any data yet. So let's click the Add Explorer button and let's hope this all works. So I'll click Add Yourself as an Explorer. MetaMask will pop up. It's going to ask me to confirm the transaction. Again, I'm on the RinkBuy test network. So this ETH that I'm sending is not real ETH. I'm going to click Confirm. Now I get a little success message here that says that it has worked, and it gives me a transaction hash that I can look up on Etherscan if I want to. And if we wait around just for a little bit until the transaction confirms on the blockchain, it is then going to just instantly pop up in this Web3 Explorers box. And you can see I also get the confirmation from MetaMask as well. This smart contract was just an example, but this likely isn't the sort of thing you would use blockchains for. It certainly is possible that you might need to do something like this on a blockchain, but if you don't need the benefits that blockchains provide, like decentralization, payments, anonymity, censorship resistance, digital property, things like that, then using a smart contract to do something like this is really just an expensive and slow way to do something you could have done with a centralized provider like Firebase, Azure, DigitalOcean, or whatever else you want to use. But where smart contracts do shine, they shine brightly, and they are opening a whole new world of possibilities. So if you like this video, please feel free to leave a like and subscribe, and I will see you in the next video.